Hello to everyone, I'm Paulo Sorricchio, Master Student at DigiPen Institute of Technology, and with this video I'm going to show you the project I did for the CS561 course. The CS561 course is Advanced Animation and Modeling Techniques 2, and basically I chose to implement Gerstner waves. In particular, in this project there are two big modes. Gerstner waves that are nothing more than sine waves overlapping each other, where the user has two submodes where he can select whether the user wants to specify the amplitude, the phase shift of the waves, or using the dispersion relation that I'm going to explain once we see the actual implementation. And the second part, that is what I definitely prefer, is the filling spectrum mode, where I'm actually defining the power spectrum of the wave, and basically I'm doing an inverse Fourier transform to come up with the actual position for each vertex of the waves and having the final wave. But in this approach, there is actually an inverse approach, because the user doesn't specify directly the characteristics of the wave, specify the energy of the wave, the power spectrum, and from there the inverse Fourier transform comes up with the equations for the waves. So we can start seeing, well, this is this is a plane of triangles. I'm using a simple phone lighting, and since I'm modifying the vertices every frame, I have to recalculate the normals every frame. I'm using a dynamic vertex buffer to allow us to have good performances, because basically I'm writing into the vertex buffer every frame. So we can start seeing that there's a classic N-Twig tool over here, and the light is completely dynamic, so we can change the position of the light, or the colors or the characteristic of the light, so the diffuse color, the specular color, and whatnot. But let's go into the actual water simulation. So let's start adding a wave. As we can see, this is nothing more, as I said, than a sine wave. It's just a sine wave, and we can see here all the parameters that are defining this wave: the amplitude, the phase shift, the wavelength. So as I said, there are the random mode, fixed speed mode, and the random mode dispersion relation mode. I left the user the possibility to modify this value like amplitude. So if I put amplitude 3, of course we see that the waves are higher than before. And even the phase shift just translates the sine wave on the wave direction, that in this example is the y, positive x axis, sorry. And so let's try to modify some use the random mode fixed speed, so we can modify mean and deviation for each wave. And let's try to put some values. 0.5 division 0.1, it's okay. Phase shift is not really a parameter that changes. The length, it's actually interesting, and the speed, let's say 4, it might be too fast. Okay, we see that the wave changes in real time. And what is really, let's put a lower amplitude. There we go. Okay, what we can see is that basically we can add all the waves we want, and with this add wave button, and for each wave I'm generating the proper bar. So each wave has its own bar. We can use different modes for different waves. So let's clean all the waves. Let's start with another new wave. Let's see, it was 0.4, 0.4, it was 5, the length was 4, and the speed was 4, not 54. Okay, now let's try to put other waves to because I mean it's quite obvious that this is not really a good representation of the sea, because we can see a pattern. Sea is liquid is chaos. When you see a surface of the water, you don't really see a pattern repeating. this is obvious that it is a sine wave. So let's see, let's try to add a wave and make it more interesting. We can obviously change the directions, so even this, let's say 0.2. Even this now, we can see that even though the pattern is still visible, we can see that basically there are two actual sine waves overlapping. There's one going in this direction. I can disable the debug drawing. In this direction, toward the top right corner of the screen, and one going in this direction, toward the bottom right corner of the screen. And basically, yeah, we can play with all sorts of parameters, and you can try different parameters and see what fits better with what you want to achieve from the simulation. And just to show the basically the random mode dispersion relation, you define just the depth of the sea and gravity, and from there these parameters are updated in real time. So let's try to put these parameters, and as we can see, these parameters generate what I had before. Let's try to decrease gravity. Let's put a gravity of 5. That's why simulations are cool. You can simulate things that don't exist, like gravity 5. And as we see in the example, the gravity is lower, and it changed, among other things, the speed of the water. So if we put a higher gravity, like 15, it's a bit faster, not that much, and the depth influences the speed as well, and in this case even the phase shift, because now the waves are not overlapping perfectly, but as you can see, there are some parts like now they're overlapping, but now they're almost opposite. That's why they tend to go back to the plane. And yeah, we can change this parameter. This is not, and we can definitely certainly try different configurations. And as I said, we can add as many waves as we want, so the performances are not influenced by this. And well, of course, yeah, this is actually creating something that is not. Whoa, yeah, this is definitely not realistic. And we can delete each wave on its own. Remove wave, the button here. So let's remove a couple of waves. Well, actually, let's remove almost all of them. Okay, and here we go. Or we can delete all waves. As we can see, this is just a note. I'm basically this is the timer, a timer from the start of the simulation, and this particular mode is time-based. Therefore, we can basically go back in time, and it's gonna reproduce the same state as before, because it's completely dependent of time. So, of course, now we can go back and forth in time, and so this allows us to see. Okay, I saw something at a specific time. I want to reproduce that effect. I just have to see the time, and boom, I just set the time 100, and this was a simulation at specifically 100. So yeah, this is the first part, what I call the Gerstner waves, the sine waves. Now I'm going to show you what I think it's the best part of this project, that is the filling spectrum mode. As I said, with the filling spectrum mode, let's clean all the screen. With the filling spectrum mode, the user defines fewer parameters. We define just the amplitude, the direction of the wind, the speed of the wind, the gravitational constant, and the depth of the water. And after that, there's no, this is, as I'm saying, I'm defining the spectrum. So this is not, it's related to the whole surface of the sea. It's not related to a single wave. From this, the inverse Fourier transform will calculate all the waves, basically. It's like all the parameters you have seen before are all calculated by fast Fourier transform, by inverse fast Fourier transform, of course. To do the, I'm saying fast Fourier transform because, of course, I have to do that every frame. So basically, it was impossible to do a Fourier transform. I took an implementation from my professor of the fast Fourier transform, and I'm doing that every frame. Unfortunately, I'm doing that on the CPU side. The program still runs smoothly, but there are implementations of fast Fourier transform on the GPU, and that is definitely way faster than doing that on the CPU. So let's see. Let's try to play with values. Let's put just along the x-axis. Let's put this. One speed. Let's put 3 rotational constant. Let's be ready. Say let's put around 9 and water depth. Let's put 100. There we go. As we can see now, I'm gonna remove this layer. Okay, as we can see, the simulation is definitely better than before. The impression is definitely more realistic. At least this is what I think. As we can see, this is more. We cannot see a repetitive pattern, even if there actually is one if you really look carefully. But this is definitely more realistic. It looks definitely better than just sine waves. And what is cool is that in this modes, even the parameters are really intuitive. So if I just modify the amplitude, I'm just gonna see a more agitated C. So I definitely wouldn't like to be here in the middle of a storm. Well, it's actually not a storm. If you want to unleash the storm, is quite easy. Just put this value to 5, and this starts to be quite crazy. Or even modifying the wind speed is. I'm actually modifying the wing speed actually modifies the basically the frequency of the waves, among other things, but that is the most obvious one. So 1 is it influences, of course, even how much the amplitude is influencing the waves. And if I put a lower gravity, basically the speed is gonna be slower. Because it's like if the waves were less attracted by the basically the ground, the center of the earth. And if we put a shallow water, well, this doesn't really change as much as this change. Okay, now we can see. Let's put the values of before. Let's put 3. If I change the word, basically the word depth doesn't influence the simulation as much as the other parameters. It's actually it's really easy to see here. Okay, each wave has more energy when the depth of water is higher. So now we see. Look at the peaks here. For example, this one. While with this has definitely less peaks than before, and so basically we can unleash the Kraken. This is apart from, I mean, you can play as usual. You can play with I prefer not to put any. We can change the direction of this, and that changes how the whole simulation behaves. So this, for example, is this is really cool. This this is almost calm. There's just a long wave. I definitely prefer this. I definitely prefer this simulation. It's definitely more realistic than just sine waves. It's definitely better. I really like it. And so as I said, the light is completely dynamic, so we can see. Whoa. Oh, that was cool. And so that's pretty much it. As usual, you can download my projects at www.carlosrique.com. Feel free to try them. If you have any suggestion or just impression, just send me an email. I'm more than welcome to. If you have any question, or more than welcome to answer. And I hope you guys enjoyed this video, and see you guys next time.